Okay, this video is for section 10.2 and still discussing circles, but instead of looking at a circle as a whole and the different things that can interact and relate to it, what we want to do is we want to start taking that circle and we need to break it down into some pieces. To do that, we need to create some new definitions to be able to look at how those pieces are going to be named, and then set some definitions and some other applications that coincide. So first of all, when you take an entire circle, here's my circle, there's the center, okay? Out on the circle, I'm going to designate a couple points. This is X and this is Y, okay? Now, when you look at the distance, the part of the circle, I don't want to say distance here, the part of the circle from X to Y, that unbroken part of a circle is called an arc. So XY, we're going to put this little umbrella over the top of it here. Okay, XY is called an arc, A-R-C. Okay, now when we talk about arcs, there are two things that we can do. We can find the measure of an arc, or we can find the length of an arc. Now, arc length is something that we're going to save for another time. What we want to look at here is what are the different kinds of arcs that can occur in a circle, and how do we find their measure? Okay, so with this one, the arc XY represents the part of the circle from X to Y. When that arc is less than a semicircle, remember, a semicircle is half of a circle, then this is called a minor arc. Okay, a minor arc. And it's important to note that when you label a minor arc, it only requires two letters, place where it starts and the place where it stops. Okay, so from X to Y is a minor arc. Now, let's designate some other points up here. If I go through Y and through the center and find the other point over here, here's Z. By creating that diameter, I've now taken the circle and divided it into two semicircles. Okay, with the semicircle, okay, that means that I have a new type of arc, and therefore I have a new manner in which I need to name it. So I'm going to designate another point over here. I'm going to call it W, because when you name a semicircle, okay, there are two of them there. They both start and stop at the same point, so how do you know which one is which? Well, I'm going to go, if I want the top semicircle, then I can start at Z, go through X, and then stop at Y. That would be an example of a semicircle. Okay, now there's no order. I mean, you do have to start and stop at the end points of the arc, but a point that you choose in between can be any point. If I wanted to name the bottom, just for contrast here, okay, on the bottom, let's label this, we have V. I could talk about the semicircle YVZ or ZWY. They both start and stop at the same points. They all go the same direction. So all of those are different ways of naming the exact same semicircle. So you need a point where it starts, a point where it stops, and a point in between that tell you what direction to go. Okay, so a minor arc is the only one that requires two letters. Okay, a semicircle requires 3. And then the third category, if let's say, for example, I go, this one has to be bigger than a semicircle, has to be bigger than a semicircle. So if I go from Y to Z to W, okay, starting up here, Y, going around to Z, and then stopping at W, okay, that would be another arc called a major arc. Oops, sorry. M-A-J-O-R. How about we try that again? M-A-J-O-R. A major arc. So all of the arcs, which are pieces of a circle, okay, have to either require 2 points or 3 points with the little umbrella symbol over the top. Now, in terms of their measure, a minor arc will always measure less than 180 because it has to be smaller than a semicircle. Okay, a semicircle, which is half of a circle, must always equal 180. And then a major arc has to be between 180 but less than 360. Okay, when you take all of the components of a circle that form a circle and add them together, okay, then you have a full circle must be 360 degrees. Okay, so again, you're going to be asked to name some of those. Okay, now another thing they talk about here, another nice relationship to remember, they talk about what's called a central angle. And we'll have some different variations of this here in a little bit, okay? But if I take a circle and from the center of that circle, I draw 2 radii, okay, here and here, okay? Here is, let's call this B, circle B. Here's A, here's C, okay? So I can see arc AC formed, and that arc AC is a minor arc. Okay, but look at where the 2 radii intersect here. Okay, that value N, if I call it N, is called a central angle. So that would be the measure of angle ABC equals N degrees. Okay, now that is a central angle. And the reason we call it a central angle is because the vertex of the angle is at the center. Okay? Now, why is that nice? Because if this is n degrees, then this out here must also be n degrees. So if this is 60 in here, then this is 60 out here. And we can use a protractor to measure this. Once I know what this is, then I know what this is as well. Okay, so that'll be kind of another important part of being able to relate those two things and finding some missing angle measures. Okay, that's pretty much all. There's some postulates and definitions that I'm kind of just going to go through with you real quick, and then we'll get to some of the homework problems. Look at postulate 26 on the sheet here in this box. It's called the arc addition postulate. It says the measure of an arc formed by 2 smaller adjacent arcs is just the sum of their measures. So we've had segment addition, we've had angle addition, okay? What this thing says is in the same regard that we could add those, okay, we can now add these. We can add arcs in the same manner. So if I know I have, again, here's a circle. Okay, here's AB. Here's BC. So I know that AB, the arc AB, when added to the arc BC, has to equal the arc AC. Okay. Now, notice that all of those were minor arcs. Okay. If I were to move those so that it's a major arc, be careful. When the sum of the two becomes a major arc, then you have to rename it using 3 letters, not 2. Okay. So if I do this, for example, and I say, well, AB plus BD, okay, that doesn't equal AD on the other side. It equals ABD, which is a major arc, and which is the combination of these two smaller minor arcs. Okay, so be careful. Be careful. I'll talk some about these other ones as we look at some of the exercises. But Theorem 10.4, in the same circle or in congruent circles, 2 minor arcs are congruent if their corresponding chords are congruent. Okay, so meaning chords, remember, have to intersect the circle twice. So over here is AB. Okay, over here is XY. And here is a chord. Here is a chord. Okay, this thing says if AB, the arc, equals or is congruent to XY, the arc, then the segments, the chords AB and XY, also have to be congruent. So if this is congruent to this, then this has to be congruent to this. Okay, notice how I'm using the congruent slashes again to match up those congruent pieces. Okay. And I guess one more here. Because the other ones are kind of converses of each other, and so same idea, just in a different order. Okay, so it says theorem, if a 10.5, okay, if a diameter is perpendicular to a chord, then the diameter bisects the chord in the arc. Okay, so here is a circle. Here is a diameter. Here is a chord. Now, the theorem says that if these two are perpendicular, which means you got to see a right angle symbol there, then it means this and this have to be the same, and this have to be the same. Okay, so that's another, again, a nice little relationship on being able to match up some corresponding parts. They'll try to throw that at you in some exercises as well. Okay, so here's what I want to do. Okay, I'm going to go ahead and stop this video. This is just the notes for this unit. Okay, what I want to do next is on the next video, I'll just take you through problems in the homework. Okay.